Hello, everybody. So, today we're going to work on our final lesson of Chapter 7, and we're going to be working on problem solving, finding unknown lengths. We're on page 345 of the 5th grade Go Math textbook, and the strategy we're going to use today is a strategy known as guess, check, and revise to solve problems with fractions. So, let's look at the unlock the problem. Sarah wants to design a rectangular garden with a section for flowers that attract butterflies. She wants the area of this section to be 3/4 square yard. If she wants the width to be 1/3 the length, what will the dimensions of the butterfly section be? All right, so what do we need to find? We need to find the dimensions of the butterfly garden. What information do I need to use? Well, the part of the garden for butterflies has an area of 3/4 square yards, and the width is 1/3 the length. So it says 1/3 the length. The total area is 3/4 square yards. So how will I use this information? Well, again, we're going to use the strategies guess, check, and revise. So I will guess the sides of the butterfly area. Then I will check my guess and revise it if it is incorrect. All right, so I can try different lengths and calculate the widths by finding 1/3 the length. For each length and width, I find the area and then compare. If the product is less than or greater than 3/4, I'll need to revise the length. So remember now, area is found by multiplying length times width. So we know that the area in this problem is 3/4. So the two factors have to be multiplied to get 3/4. So they're saying, okay, let's just guess 3/4. Okay, the area has to be 3/4. Let's try it. So let's take one. They're saying the length would be 3/4. So the width is going to be 1/3 of that. So 3 times 1 is 3. And 3 times 4 is 12. And that gets reduced to 1/4. All right, well, now, so if we're saying the width is 1/4 and the length is 3/4, we multiply length times width. 3 times 1 is 3, and 4 times 4 is 16. Well, 3/16 is not equivalent to 3/4. Okay, so that's too low. So let's try a longer length. And this time they're saying, all right, well then let's go 9/4 or 2 1/4 for one of the sides. So 9/4, and we're going to multiply 1/3 of that. We want 1/3 of 9/4. Well, 1 times 9 is 9, and 3 times 4 is 12. I can reduce by a factor of 3, and 9 divided by 3 is 3, and 12 divided by 3 is 4. So we're saying 9/4. Sorry. Yes, I'm sorry. 9/4 times 3/4. If we're saying our length is 9/4, 1/3 of it would be 3/4. So if we multiply, we get 27/16. Well, that's bigger than one whole, right? That's larger than 3/4. How do I know? Because the numerator is bigger than the denominator. So this is a fraction greater than 1. So this would be 1 or more square yards. I want 3/4 square yards. So I now have to try a shorter length. Is this the most efficient method? Definitely not. Okay, but we can guess and check. So let's see. 3/4 was too small. 9/4 was too big. How about going right in the middle? Why don't we say 6/4? What is 6/4? 6 divided by 4 is 1, and 2/4 are 1.5. So we can say 1.5 or 6/4. All right, so 6/4, we want to take 1/3 of 6/4. 1 times 6, 3 times 4. 6 times 1 is 6, 3 times 4 is 12. So we're saying the length is a half. All right, so let's do this. 1/2 times 6/4. Well, 1 times 6 over 2 times 4, 6/8. What can you reduce 6/8 by? By a factor of 2. We would get 3/4. Hey, that's what we wanted, right? So the dimensions are going to be 1/2 by 1.5, because 6/4 is the same as 1.5. All right. Let's look at 346. Try another problem. All right. Marcus is building a rectangular box for his kitten to sleep in. He wants the area of the bottom of the box to be 360 square inches, and the length of one side to be 1 3/5 the length of the other side. What should the dimensions of the bottom bed be? Should the bottom of the bed be? So we want area equals length times width. They tell us that the area is 360. We have to figure out the length and the width. All right, so what do? I find the dimensions of the bottom of the bed. What information do I need? Well, the area is 360 square inches. One length is 1 3/5 the length of the other side. Well, how I use? We're going to use the guess, check, and revise method. I will guess the two sides. I will check to see if it is correct. I will revise if not. All right. So let's look back at our other example and what were those steps for it? Well, they started with our guess. We figured out the 1/3 of the length. So let's put in guess as one column. The next area is going to be the actual. We're going to take 1 3/5 of it. We're going to check our answer, and then we'll revise as needed. Okay. All right. So 360. What are two numbers multiplied together that might give me 360? Well, let's see. What if I said 20? I don't know. I'm just guessing size, right? Could 20 even be one of the sides? Let's see. If we were to simplify, we'd get 160. Yeah, 8. So we could say it's an 18 by 20. So I'm going to take the larger factor, 20, and I'm just going to guess. Okay, I'm going to guess that one of the sides is 20. Well, they told me that the other side is 1 3/5 as much as that. So let's see. 1 3/5 times 20 equals 8/5 times 20 over 1, right? 1 3/5 is the same as 8/5. 5 times 1 is 5, plus 3 more is 8. 8 over 5. 8 times 20 is 160 divided by 5. So 1 3/5 times 20, divide that by 5, we get 32. So our guess is 20 times 32. Well, what is 20 times 32? 32 times 20. Well, I know that anything times a multiple of 10 has to end in 0. So 2 times 32, 640. 640 square inches. That is too big because it was supposed to be 360 square inches. All right, so too high, try a shorter length. All right. I don't know. Let's try 10. I know that 10 times 36 would be 360. So I'm going to take 1 3/5 of 10 and see what that gives me. So 8/5 times 10 over 1 is 80/5. 80 divided by 5. 16. So we're saying our guess this time is 10 by 16. Well, 10 times 16, that's 160 square inches. That's going to be too low. So now we have to try a longer size. How about something right in between again? So 10 was too low, 20 was too high. So let's try 15. So 1 3/5 times 15. Now my guesses might be different than your guesses. These are just possible guesses, okay? So there's no right or wrong with the guesses for the sides. I'm just guessing sides that I know are factors of 360. Okay? So 15 times 8 is 120. I know that 8 times 5 is 40. 8 times 1 is 8, plus 4 more is 120 over 5. 120 divided by 5 is 24. All right, so I'm saying maybe the answer is 15 by 24. Well, what is 15 times 24? Five times 4 is 20. Regroup that as 2 10s and 0 1s. 5 times 2 10s is 10 10s, plus the 2 regroup 10s is 120. We're moving over to the 10s, so I know that the product has to end in a 0. So 1 times 4 is 4, and 2 times 1 is 2. Hey, that came out to 360. So that is right. So it's 15 inches by 24 inches equals 360 square inches. So the kitten's bottom of the bed will be 15 inches by 24 inches. What if the longer side was still 1 3/5 the length of the shorter side, and the shorter side was 20 inches long? What would the area of the bottom of the bed be? Oh, that's was one of our guesses, 20. So we know that 1 3/5 of 20 was 32. So we'd have 20 times 32. And we already multiplied that out, and we got 640 square inches. So that's what it would be if we kept it the same, or the same 1 3/5 the length of the other side. And we're saying by 20, well, that was one of our guesses. And 1/5 of 20 was 1 3/5 of 20 was 32. So if the one of the lengths is 20 and the other side is 32, multiply that together, we get 640 square inches. All right. Number 1. When Pascal built the doghouse, he knew he wanted the floor of the house to have an area of 24 square feet. He also wanted the width to be 2/3 the length. What are the dimensions of the doghouse? Well, again, we're trying to find two numbers that multiply together give us 24. Well, 4 and 6 seem like reasonable guesses. Okay, 4 times 6 is 24, right? So let's take 2/3 of the 6. If it comes out to 4, then that's the right dimensions. So 2/3 times 6 over 1 is 2 times 6 over 3 times 1. And 2 times 6 is 12, and 3 times 1 is 3, and that equals 4. So my guess is right. So the dimensions of the doghouse are 4 feet by 6 feet. Number 2, what if Pascal wanted the area of the floor to be 54 square feet and the width still to be 2/3 the length? What would the dimensions of the floor be? All right, well, 54 square feet. Well, we know that 9 feet times 6 feet is 54, right? So let's take 2/3 of the larger number, the 9, and we're hoping to get 6. So I can write 9 as 9 over 1, and 2 times 9 over 3 times 1. 2 times 9 is 18, 3 times 1 is 3, that gives me 6. So yes, so the dimensions would be 9 feet by 6 feet. 9 feet by 6 feet. How about number 3? Leo wants to paint a mural that covers a wall with an area of 1,440 square feet. The height of the wall is 2/5 of its length. What is the length and height of the wall? All right, so let's try some guesses. Let's see. Is 40 a factor of 1440? I think it is, because 4 is a factor of, if I divide it by 10, I'd have 144 divided by 4, and 4 is divisible by 4, so 144 is divisible by 4. So let's try 3. 3 times 40 is 120. That would leave me a remainder of 24, bring down to 0, so 36. So I'm going to guess 40. I'm going to take 2/5 of 40, and that's going to give me 80/5, which equals 80 divided by 5 is 16. All right, so we're going to try 16 by 40. 16 times 40. Well, I know if it's multiplied by a multiple of 10, it's going to end in a 0. 4 times 6 is 24. And 4 times 1 is 4, plus 2 more is 6. So I get 640. Okay, so it's not 16 by 40, is it? That's going to be too short. So we're going to have to try something longer. Try a longer length. That was pretty low, 640. I think I'm going to try to double it, 80. So I'm going to take 2/5 of 80. That's going to be 160 over 5. All right, because 80 times 2 is 160 and 5 times 1 is 5. 160 divided by 5 would be 32. So we're saying let's try 32 times 80. 32 times 80. Again, we know it's going to end in a 0. 8 times 2 is 16. 8 times 3 is 24, plus 1 more is 25. Oh, 2,560. That is way over what I want. So that's too long. So we're going to have to try a shorter length. Well, we might as well try something right in between. What's in between 40 and 80? Well, it would be 60, right? So let's try 60. 60. 2/5 times 60 over 1. That would be 120 over 5, which equals 24. 120 divided by 5 is 24. So we're guessing that our dimensions are 24 by 60. Okay, well, let's multiply 24 by 60. We know it's going to end in a 0. 6 times 4 is 24. 6 times 2 is 12, plus 2 more is 14. That's 1440. So that works. So the dimensions are 60 by 24. The length is 60 and the height of the wall is 24 feet. So 60 feet by 24 feet. Number 4. Barry wants to make a drawing that is 1/4 the size of the original. If a tree in the original drawing is 14 inches tall by 5 inches wide, what would be the length and width of Barry's drawing? Well, we're going to take 1/4 of each of the dimensions. So it's going to be 1/4 of 14 times 1/4 of 5 inches. So 14 times 1 is 14 over 4. We can reduce that by a factor of 2. So 7/2. So 7/2 by 5 times 1 is 5 over 4. So 7/2 times 5/4. Or we can turn it into mixed numbers. 7 divided by 2 is 3. So 3.5. 3.5 is the length. 3.5 inches. And the width is 5 divided by 4. 1 1/4 inches for the width. All right, number 5. A blueprint is a scale drawing of a building. The dimensions of the blueprint for Patricia's dollhouse are 1/4 of the measurements of the actual dollhouse. The floor of the dollhouse has an area of 864 square inches. If the width of the dollhouse is 2/3 the length, what are the dimensions of the floor on the blueprint of the dollhouse? All right, well, there's a couple ways we could do this. I'm going to go ahead and find the dimensions of the larger one. Okay, so I know that something times something is 864. So area equals length times width. And we know that we have to come up with a product of 864. I think 40. I don't know. I'm just trying to come up with a number that, if I multiply them together, will give me 864. It could be like 40 times 20. So that's kind of where I'm starting. So I'm saying, I'm going to say 42. And if I subtract that, oh no, that would be 2. And none. All right. So let's just try it. My guess is going to be 42 inches. The width is 2/3 of 42. So what is 2/3 of 42? 2/3 of 42 is 84 divided by 3. 3 into 84 is 2. Subtract 28. So we're saying our guess is 42 by 24. And we need to see if 42 by 24 is 864. So 42 times 24. 4 times 2 is 8, and 4 times 4 is 16. We're moving to the tens, so 2 times 2 is 4, and 2 times 4 is 8. Add that together, we get 8, 10. We get 1,008. That's too big, right? So too high. Try shorter length. Wasn't that far off. Let's try. Let's try 30. So 2/3 of 30. 30 times 2 is 60. Divide by 3 is 20. So let's try 30 times 20. That's one of those problems we can do in our head, right? 10 times 10 is going to be 100. So 30 times 20 is going to be 600. So 600 square inches. So that's going to be too low. So let's try something longer. All right. So 30 was too low. 30 was too low and 42 was too high. But we're not that far off on either one. So let's go right in between. Let's try 36 inches. 2/3 of 36. 36 times 2 is 72. Over 3 times 1 is 3. 72 divided by 3 is 24. So let's try 36 times 24. 36 times 24. 6 times 4 is 24. 4 times 3 is 12, plus 2 more is 14. 2 times 6 is 12. 2 times 3 is 6, plus 1 more is 7. 864. That's what we want. All right, so we want a length of 36 inches for the length by 24 inches for the width. (36 by 24). All right, number 6. Beth wants the floor of her treehouse to be 48 square feet. She wants the length to be 3/4 the width. All right. The length has to be 3/4 the width. Use the strategy, guess, check, and revise. Using the strategy, Beth guesses the dimensions will be 4 feet by 12 feet. Is Beth's guess correct? Well, let's see. 12 times 4, that is 48. So that is 48 square feet. But is the length 3/4 of the width? The width is 12. So is 3/4 of 12 4? If not, then she's not right. 3 times 12 is 36. 36 divided by 4 is 9. So 9 times 12 is not 48. So no, she's not correct. No. While 4 times 12 is 48 square feet, 3/4 of 12 is not 4. And if 3/4 of 12 is not 4, then 4 times 12 is not, it wouldn't work. Okay, because she's not going to have 4. All right, Sally has a photograph that has an area of 35 square inches. She creates 2 enlargements of the photograph. The enlargements have an area of 140 square inches and 560 square inches. In each photograph, the length is 1 2/5 times the width. Select which of the following could be the dimensions of the original photograph, or one of the enlargements. Mark all that apply. All right, so we know that our 2 numbers multiplied together have to give us one of those square inches for answers. But then I do have to make sure that the length is 1 2/5 times the width. So 5 times 7, that is 35 square inches. Okay, so that could be an answer because it matches the original. 28 times 20, that's 560 square inches. So that could be this one. 7 times 20, that's 140. So, okay, so far all of them match the area of one of our pictures. 21 times 15, 315. So, okay, so we can eliminate D. There's no way that's going to be, because it's 315 square inches. 10 times 14, I know that that's 140 square inches. All right, so A, B, C, and E could be possible answers, but now we have to see if the length is 1 2/5 the width. So take the smaller number and see if you get the larger number. So 10 times 1 2/5. 10 over 1 times 7/5. 70/5. So when we divide 70/5, we're hoping to get 14. So 70 divided by 5. 7 take away 5 is 2. Bring down the 0, we have 21s. 20 divided by 5 is 14. So yes, we have 10 by 14. So E is a right answer. 7 by 20. Take the 7 and multiply by 7/5. Because it has to be 1 2/5 as long as the length. The width's the longer part. Okay, so we're going to go 7 over 1 times 7 over 5. 7 times 7 is 49. divide by 5. 49 divided by 5 gives me 9 and 4/5. So 9 and 4/5 times 7 is what it should be. So C is not right. Okay? Because 1 and 2/5, 7, is 9 and 4/5. And 9 times 7 is not going to get me 35. It's not going to give me 140, and it's not going to give me 560. So it doesn't match any of those. 20 by 28. So multiply 20 by 7/5. 7 times 20 is 140 over 5. 140 divided by 5 is 28. That's what the other number was. So that one works. And now multiply 5 times 7/5 and see if you get 7. Okay, so we're saying, what is 7/5 of 5? Okay, and if it comes out to 7, that's the right answer. Remembering it'll work. 5 times 7 is 35. 5 times 1 is 5. 35 divided by 5 is 7. So that one also works. So that's our discussion of multiplying fractions at the 5th grade level. So in the next chapter, we're going to start working on dividing fractions. So until then, I will see you soon.